Okay, so here we are, outcome number 3, part 2. So we just did our power calculations, and now we're looking at power rating. So many electrical appliances have power ratings in watts marked on them. So for example, on light bulbs, kettles, hair dryers, speakers, they're on their cell phone chargers. It'll tell you what the power rating is on them. Okay, and then the energy guide labels, there's a bigger label, and this is if you're buying big appliances. They have a little bit more information. They tell you on average how much kilowatt hours is used in a year, and they tell you its efficiency, and then you can look at prices, and then you can make a decision about which large home appliance you're going to purchase by using this information. And you could see this. I don't see mine on my stove anymore. Dishwasher, it's on the side, so you probably can't see that. Furnaces, they are posted on the side of the furnace, on the air conditioner as well. I'll tell you where I can see it. The sticker is still on my dryer, so maybe because of the heat of the dryer, it stayed on there. It's also on my washing machine, and there's one more spot. Oh, inside of my fridge in the house, I can actually see this. And on a dishwasher, it was originally on the front of it as well, but I was able to peel that sticker off. Okay, and so you make your decision based on how much energy it uses in a year and what efficiency level it is and cost and features. Okay, and so here's some average power power ratings, and then here is how many kilowatt hours are used. Sorry, how many megajoules are used per year. And then, of course, there's an easy way to calculate efficiency. It's how much energy is converted into one form divided by how much energy was given times 100. So basically, it's useful energy output divided by useful energy input times 100 with the percent sign. Okay, now we know how to figure out energy. We use the formula energy equals power times time. In the last assignment, energy is still in joules, power is still in watts. Really careful here, time has to be in seconds for that formula to work. So let's go ahead and try some. I don't even really refer to this. I know there's no such thing as 100% efficiency in energy transfer. So I always just go small number divided by big number times 100. Is it very scientific? No. But then I don't also have to try and spend time memorizing this formula. By the way, all these formulas will be given to you on your quizzes and on your tests, and on your unit tests. It'll be on the board, and on your final exam, it's given to you on an equation sheet as well. So let's go ahead and try this. In a video game, 600 joules of energy is taken in from an outlet. 450 joules is its output energy. So what do I have? I have 450 joules going in. So 450 divided by 600, which is supplied, times 100%. And I'm hoping the background noise isn't interfering with my recording. And so that gives me 75% efficiency. Okay, and so that's one. Let's try next one. Toaster is plugged into an outlet where 900 joules of energy enters and 700 joules is used to toast the bread. Calculate efficiency. So once again, energy output, or 700, divided by energy input, 900, or in my case, I say small divided by large, times 100%, tells me my efficiency is 77.8%. Okay, I think I have one more here. 60 joules of energy goes into a light bulb every second. It's only 5% efficient. How many joules is converted into light? So really, what's 5% of 60? So 0.05 times 60 means that only 3 joules of energy that goes into an old incandescent light bulb actually gets changed into light. The rest of it, the 57 joules, is turned into heat. So the old style light bulbs were way more efficient as heaters than they were as actual light sources. So here is a big long problem in the notes. It's kind of a neat question. It's beyond science 9, but here it is. A 1,000-watt kettle runs for 4 minutes to boil water. This is how much energy it takes to heat the water. How much is the efficiency? So the first thing you need to do is figure out the energy usage, right? And so you have 240 seconds and 1,000 watts. P equals I times V. Down here somewhere, P equals I times V is 24,000 joules, and then small divided by big times 100, and you can get the efficiency as 81.7% out of there. So like this, 1, 2, 3 step problems, fairly representative of what you'll be doing when you get to Science 10. But for Science 9 on the government exam, they don't want you doing more than one step problems. So you're not going to see this. I just provided to you as an example of a more complicated question so that you could see how they work. And that is the end of outcome 3 notes. There is a efficiency worksheet that I will give you to work on, and then we are going into outcome number 4 next, the last outcome of the year. Before we get there, I'm going to show you some other things. Here it says, look at this. There's your calculate efficiency. So 100,000 divided by 800,000 times 100 gives you 12.5%. This is a numerical response question, so we would actually have to, there'll be boxes to fill in, 12.5, and that is your answer. So I'm just reminding you and showing you this because, final exam is coming up fairly soon, and there is 5 numeric response questions on there. So that's one kind where you have to do a calculation. There's another one where you could have to rank things from smallest to largest, and so this one, half the question is missing, but it would tell you Jupiter and the universe and the sun and a nebula, and it would have numbers beside them, and you have to put them in from smallest diameter to largest diameter. You did something like that on your unit test. Here's one where you have to classify whether it's discrete or continuous. So they'll give you numbers here, and you've done questions like this on my test as well. So the trait is gender. So remember, discrete is this or that, and continuous, there's thousands of possibility. So gender is discrete. There's limited choices. Even if there is, and I don't know the exact number, but I know there's definitely more than 2 gender right now. You would it'd still be discrete. Continuous, there's thousands of choices. So height is continuous with the 2. Hand size, there's thousands of sizes of them too. So your correct answer would be 1, 2, 2. By the way, there's always 4 blanks. If you don't need to use a blank, don't use it. Don't add extra numbers. It makes it wrong. Okay. Here's another one. The choose your adventure question. This is awesome, where you have to, this has multiple possible answers. And in this case, you had to put together the sense, the organ, and the type of stimulus together. And so hearing, 1, goes together with the ear, 6, which goes together with sound. So 169 is a possibility. But smell goes, number 2, goes with the nose, 4, and odor. So the answer could be 2, 4, 8. And vision goes with the eyes, 3 and a 5, and that goes with light, 7. So they actually have 3 different answers for it. Make your own story. Love those. Hopefully there'll be some on upcoming PATs. Quick reminder that you will need to know the Wimmis symbols for your PAT as well. And so there is the flame. There's the flame over circle. That's for oxidizing material. This is a gas cylinder. This is using the what is now the accepted Wimmis symbols. There's exploding bomb for explosive or reactivity hazards. There's biohazard. That's not new. By the way, this one's not new. This one's not new. This one's not new. This one's not new. Corrosive is not new either. Okay, but explosive bomb is. Exclamation mark is new. This may cause less serious health effects compared to And then here's it may cause or suspected of causing serious health effects. I call it the exploding chest one. It's called health hazard. And then skull and crossbones, that can cause death or toxicity with short exposure to small amounts. That's very, very dangerous to your health. Okay, and so that is there. And that is the end of outcome number 3.